Make it. So the 220, 230 review, I'm going to start off with the what you missed or what's new first. And then I already have a couple questions. I'll review question 8, come back, and then question 25 is part of the heparin questions. But during the review, if you have a question, raise your hand, or just type it into the chat, and then I'll get to you. Um, and and then we'll go from there. So, all right. So what I'm going to start off with is these infusion questions because they actually help prep you for what you're going to see with the heparin questions in just a little bit. Um, so we'll start off with these here and we'll kind of go forward. So for those of you who didn't see, hopefully you know at this point, being third semester, uh, these practice reviews are on the OneDrive share folder. It's the link, the same, it should be in the same kind of where you found the link to this Zoom meeting, plus the link to the YouTube site where this will be shared. The recording will be shared, and then there's practice questions on the shared OneDrive folder. Those practice questions are in the Allegheny and then the 220, 230 folder. And the 25 spring is still the most up to date as of now. There might be changes, but I don't think those changes will be in effect for your test for next week. But everything we do here should get you prepped and ready to go. So I like to start with these just because they're a little bit new and a little bit nuanced, and it's a little bit about manipulating the units and the information to kind of get you started. And so this question, number 20, says that we have a 500 milliliter IV of heparin, and there's 20,000 units of that heparin in the IV. And it tells us that it's infusing at 8,000 units per hour, but they want you to convert units per hour to milliliters per hour. Now, this is helpful because this is part of what you'll be doing in the heparin protocol. So this is kind of, I call these like little workup steps. So once we get to this, we'll be fine. And then you can see this will be a repeat question. So I'll probably have you work through this on your own after we model this first one. And then there's some insulin ones, but I'll get right into uh, showing you the process and then working from there. So all we're asking you to do in these questions is convert one flow rate, units per hour, to another flow rate, milliliters per hour. The thing that's wonky is you haven't necessarily seen this yet, and so you might be wondering, well, what the heck do I do with this? So I'm going to show you what I would do with this. Um, you can set this up and start this any number of ways. I always start with the flow rate. That's just my personal preference. If you don't like that and you're choosing another way, great, do that. Um, if you're but if you're not doing the flow rate, or if you're getting the right answer, that's really all it comes down to. So I'm going to start off with the flow rate, which is 8,000 units per hour. And I don't want units per hour. I want milliliters per hour. So in order to do that, I need to figure out, can I eliminate units and replace it with milliliters? Just do a conversion. Can I do that? And the answer to that is yes, because I have this 500 milliliter of the 0.45% normal saline, and then in that is 20,000 units. So this is actually all within the same IV bag. So they're connected. So the 20,000 units is here, and the 500 milliliters goes here because it's all part of the same solution. 500 milliliters, 20,000 units. It's all connected. Okay. Or it's all within the same IV solution. So that's your available. So before I do any kind of math, I cross out units. I'm left with milliliters per hour, which is what I'm looking for. So we're pretty much done with this question. We just got to plug it into the calculator. So I'm going to take my 8,000 times 500 and divide it by 20,000. And I'm going to get a final answer of 200 milliliters per hour. So my task for you now, just to make sure we're all on the same page and that most of you or some or all of you can get this, is go ahead and solve, and I'll highlight it for this. It's the exact same question, but but I changed the numbers. Okay. So go ahead and solve for that. When you get an answer, just put it into the chat and then we'll reconvene. All right, so it looks like most of you are getting an answer of 25 milliliters per hour. So I just want to confirm that. So hopefully what you did is, again, even if you do this differently, you should get the same answer. So I'm going to start with my flow rate of units per hour, and I'm going to convert it using the same strategy I used above. I just changed the numbers, right? So everything should cancel out. So if I take 2,500 times 250 divided by 25,000. Yeah, I get the same thing everyone else got, which is the 25 ml per hour. So good. We're on the same trajectory, at least at this point. All right. So let's the insulin questions are going to be the exact same way. It's just a smaller number. Okay. So I'll let you practice those. Let's get into the heparin question. If I can find it. All right. So the heparin question. Okay. So I when I added these questions, and this is something I think will be changing at some point. When I added these questions, I just copied and pasted the entire heparin protocol. And over the years, especially for second or third semester students, the question is, well, do I fill in all these blanks when I do that? And the answer is no. You're just going to be answering the questions, and the questions you're answering are found at the actually at the end of this. You're going to calculate a bolus and you're going to calculate an infusion rate. And I'm going to show you how to navigate all that. I actually made this into two questions where you do the bolus and infusion rate for the initial phase, and then the bolus and infusion rate for after a 6 hour recheck to see, and then that we have to kind of make some changes. I also created a alternative version of this that I think is a little bit more straightforward. So I took out all the extra neuro checks and CBCs and all that kind of stuff, and I just put in the nitty gritty. So these are just some additional practice questions using this. So I'll go through the first one with all the lengthy information, and then I'll let you do these additional practice ones that you can see I've put a whole bunch in here for you to practice. These are all keyed and answered on the OneDrive folder. So, okay. So let me go back to this. So you'll probably see this on the test, okay, on your test, where you're going to have all this information, but notice that I've crossed out 3 through 9, okay? There's nothing you need to do with any of that information. The rest of this is just kind of like a guide or a chart that you're using and referencing to answer the questions. And what is the question? Question is, how much do I bolus this patient and how much do I start an infusion? So there's a couple pieces of information that are helpful to know. We need to know the patient's weight. Sometimes it'll be given to you in kilograms, sometimes it'll be given to you in pounds. But if we're following just the standard heparin protocol, the only thing that changes in these questions is the patient's weight. Everything else is going to be calculated roughly the same way, especially if they're just going to ask you the initial dosage questions, which is what I think they're going to do anyways. So step one just tells you, step one of the protocol just says to convert the patient's weight from pounds to kilograms. You do not need to write it in there. It's just a reminder to do that. Step two repeats what it says up here, where it says the bolus the patient with 80 units per kilogram. Oh, I'm sorry. The step 10 actually repeats this. So let me go back. Step two is just telling you what is your available. You have the heparin 25,000 units and 250 milliliter half normal saline. So that's your IV. And then you also have a bolus dosage strength of 1,000 units per milliliter. So it gives you those two pieces of information as you're available. Step 10 repeats what it says in the protocol beginning, where it tells you to bolus the patient with 80 units per kilogram body weight and then to start a drip at 18 units per kilogram per hour. So it just repeats the information. So a lot of this is just repeat information. So we only need steps 1 through 10 in order to answer the first couple questions, and most likely any question you might have in regards to when you get asked about the heparin protocol. Okay. The steps 11 through 15 are kind of blocked off intentionally because they're just there to tell you, like, after you've gone through the initial infusion, these are the adjustments you might need to make. So like here, you'll see it says to rebolus with 80 units per kilogram, and then to increase the infusion rate by 4 units per kilogram per hour. And I'm going to show you how to use that information and what to do with that here in just a moment. Then, and you just follow the directions. So if it tells you to rebolus with 40, increase the rate by 2, continue the current rate, decrease the rate, don't do anything, decrease the rate. You just follow the protocol. Okay. So we're going to work through these first two steps here. So A and B, and then we'll come back and do this one, uh, number 6, or after the 6 hours. So what I'm going to do is I'm just going to open up this, oops, what did I do? I want to open this up to calculate the bolus, open this up to calculate the infusion, and then we'll come back to this in just a second. Okay, I think I have enough room there. All right, so first thing is patient's weight. So I'm gonna bring everything down in just a second, but patient's weight. We're gonna convert the patient's weight into kilograms. So all I'm gonna do is take 156 divided by 2.2. I'm going to get 70.909090. So we're just going to put that at 70.9. Okay. The next thing it says is we want to calculate. So we know that it's 70.9. I'm just going to bring that number down here. So I'm just going to put it over here so we can see everything. Let's put it here. So 70.9. So we remember what it is. I'm going to need it here anyway. So I'm just going to write 70.9 kilograms. Okay. Now, this question is asking, it tells us to do a couple things. It says our bolus is 80 units per kilogram. That's why I was saying, like, I don't need to keep it up at the top of because this is getting cut off, but it tells us what to bolus with, 80 units per kilogram. So we're going to multiply this weight by 80 units per kilogram. That gets rid of kilograms. Now, the question, though, says calculate the milliliters. Okay. So if I'm looking for milliliters, I obviously can't use, right now I'm in units. So I'm going to make another conversion. And this time I'm going to try to convert, well, not try, I'm going to convert units to milliliters. So how do I do that? Well, in order to do that, I have to use the same kind of strategy that I used in the previous questions that I was showing you, where we went from units per hour to milliliters per hour. And I'm either going to use the IV information, which contains units and milliliters, or since we're calculating the bolus, I'm going to use the bolus dosage strength, which is 1,000 units per milliliter. You don't want to use the heparin 25,000 units and 250 milliliter half normal saline because that's not the bolus dose. That's your infusion dose. That's your IV bag. This is a separate vial off to the side that we're going to add to and give the patient a bolus dose right now and then they're going to start their infusion rate, or the infusion rate starts and then you add the bolus dose. However, I don't know the order of things. But so 1,000 units goes down here, and that's just 1 milliliter. Now, the reason I did this all like this is just that way we can just kind of answer the question and now have to break it up into steps. So I'm going to take that 70.9 times 80. That does give me 5,672. And I'm going to divide by 1,000. And I'm going to get 5.672. We're going to round that number to 5.7 milliliters. Any questions on how we got to the bolus? I will say that the trick to this is knowing what information to use. Even when it's rewritten and everything's kind of there, you still need to know to use the bolus for the bolus dosage strength for the bolus dose calculation, and the IV strength or IV concentration for the infusion rate. Okay. So that's how you answer that question. So that's 5.7 milliliters. If you're looking for a shorthand way of doing these or you're checking these, you're going to take the patient's weight in kilograms. So whatever it happens to be, so like I said, the thing that changes is the patient's weight. Multiply by 80, divide by 1,000, and then for a standard heparin protocol, that'll give you the bolus dosage strength. So times 80, divide by 1,000. All right, the infusion rate. Now, I'm going to have to, I think I can drag this here. There we go. Okay. So the next thing it says is to start a drip at 18 units per kilogram per hour. So this is what I'm going to do for my infusion rate. So I'm going to take the patient, 70.9 kilograms, and I'm going to multiply by that infusion rate of 18 units kilogram per hour. Now, if I were to solve at this point, I would get units per hour. And question 20, the one that I showed you and I had everyone practice, where you went from units per hour to milliliters per hour, that's what we're doing here. We're just converting units per hour to milliliters per hour, which is why I showed you what I did before. The only additional thing is now we're incorporating the patient's weight into this. So this adds a little extra complexity, but if you're following this strategy, it works this way every time I do this. So, okay. Now, the next step is, like I said, if I leave this alone, I'm going to be in units per hour. And I don't want units per hour. I want milliliters per hour. So what do I need to do? I need to convert units per hour to milliliters per hour. So I need a way to go from units, get rid of units, and get milliliters. And so I go back to my available. Okay, so this is my available section. I already used the bolus dose strength, and we're not calculating bolus, so don't use this. Use the 25,000 and 250 ml. It's a different relationship. Yeah. I think I scrolled down, so hopefully you see that now. Here's my 250 ml. Here's my 25,000 units. And then I'm just going to plug that into my calculator before I do anything. I know that before I solve anything, I'm in milliliters per hour because I've canceled out all my other units. Again, I know some of you hate the dimensional analysis stuff, but that's what we're doing. So I'm going to take the 70.9 times 18 times 250, and I'm going to divide by 25,000. And then I'm also going to get a wonky rate of 12.762. And I want to round that again to the nearest tenth. 12.8 mil per hour. There is some discrepancy about, like, should we leave this as a decimal? Should we round that up to 13 milliliters per hour? I don't know the answer to that. I've been telling students over the last several years, round to the nearest tenth. So we'll just keep consistent unless we hear otherwise. And notice that they call it an IV drip. Well, think about it. This is less than a tablespoon coming out every hour. Okay. It is dripping. It's just that we don't need to calculate a drop rate, and we couldn't because we don't have a drop factor. So most likely that's what your question will look like. It'll just be calculate a bolus, calculate an infusion. Okay. And then that's how you would do that. Now, if for some reason they give you the additional thing, so I'm going to scroll down again. And it gives us some additional information here. It says after 6 hours, we have an APTT of 43 seconds. Okay. So all we're going to do is we're going to look for the APTT range that encompasses 43 seconds. So less than 35, 36 to 44. So I'm going to follow what it says here in step 12, which tells me to rebolus with 40 units per kilogram. So that's half of our original bolus, and then to increase the rate by 2. So let's do that. So I'm going to come down. I have the same patient, same weight, 70.9 kilograms. This time I'm going to multiply by 40 units per kilogram instead of the 80 units. Then I'm going to multiply by the bolus dose strength, which is the 1 milliliter per 1,000 units. Units are gone and kilograms are gone, so I'm left with just milliliters, which is what we're looking for. And I should get an answer that's half of 5.7. So I'm going to take 70.9 times 40 divided by 1,000, and I'm going to get 2.836, but I'm just going to go ahead and round that number to 2.8 milliliters. So you can see it's not exactly half of 5.7, but we're pretty darn close there. So we'll just leave it at that. If I take 5.7, I divide that by 2, I'll actually get 2.85. And so you have to be careful because then you'll end up rounding that up to 2.9. And I think 2.8 is a better answer. This second part is where a lot of students, when they haven't looked at this stuff yet and they'll get stuck on this, is the calculating the new infusion rate and then doing the going from milliliters per hour to going from what we do with that 2 units per kilogram per hour infusion. So a lot of times people just add 2. At least this is what I did when I initially made this mistake. And I said, okay, 12.8 milliliters per hour. That was the original. The new is going to be 14.8 milliliters per hour. You can't do that because it's not 2 milliliters per hour that you're increasing it by. You're increasing it by 2 units. So unfortunately, you have to do the same steps math-wise for getting to the I'm going to scroll just a little bit here. For getting to the infusion rate in the previous steps. So if the original was 18 and I'm increasing it by 2, my new infusion rate is going to be 20 units. So if it told you to increase by 4, then it would go from 18 to 22. If you were already at 22 and it told you to decrease by 2, then you'd go back down to 20. that's how you interpret this, right? You look at the information, you look at the data, whatever the previous infusion rate was. Not that I don't think you're going to be asked that question, but if you were asked that question, like on ATI or something, just know that you would just have to adjust it based off of the previous setup, or look at what it was originally. All right, so kilograms are gone. Again, I need to go from units to milliliters. I'm not going to use the bolus dose. I'm going to use the available IV. And I'm going to take that 70.9 times 20 this time, times 250, and then divide by 25,000. And this time I'm going to get 14.18, but I'm just going to round that to 14.2 milliliters per hour. So end up being pretty close, but I think if you wrote an answer of 14.8, you're gonna get that question wrong. So like I said, on your test, this would be one question. So one question would include both these parts. Okay, part A, part B. Another question would include part C, which is that C1, C2. So it gets broken down into different layers of questions. So in the next kind of phases of the review, you can see I kind of simplified the order and the available, gave you a patient's weight, asked you to calculate the bolus and the IV drip, and then gave you some additional things to adjust for the APTT, just some additional practice. So this is all, like I said, on the shared OneDrive folder. So I'm going to give you these to practice. Um, and then if there's time, because there was another question I wanted to address, if there's time, we can come back and do a few more of these. But this is kind of like the nuts and bolts of what you should be focusing on when you're calculating these bolus uh, dose calculations. Are there any questions on the heparin protocol, calculating a bolus dose, calculating infusion rate? You'll probably have more questions as you kind of go through some of these, and I understand that. So D's good. All right. Glad to hear it. All right. So I had someone ask about question 8. So I'm going to come back to question 8. This is something that you've seen asked over the semester. I'm assuming this is the same question 8 that they asked about, which is the dilantin question. The trick to this question is you got to make sure you're paying attention to the teaspoons. Okay. So if I'm doing this calculation, if it asks for milliliters, then then you just solve for milliliters, which is what you're typically doing. But in this particular question, it's telling you to calculate for teaspoons. So what I'm going to do is I'm going to take my order and I'm going to multiply by my available. And it tells me I have 125 milligrams and my quantity is 5 milliliters, but 5 milliliters equals 1 teaspoon. So I'm just going to leave that as 1 tisp. And that gives me 2 teaspoons. This also equals, if I didn't use teaspoons, this would equal 10 milliliters. So sometimes the question will ask you the teaspoons, sometimes it'll ask you the milliliters. The point of this question is to read the question and make sure you're solving for what they're asking you to do. All right, so for those of you who have gone through and reviewed some of these things, do you have any questions from any of these other things, or do you want me to go through some more of the heparin protocol questions?
Dr. Red, could you go over question? I think it's number 15, if it's aligned with the test that they gave. And I'm just trying to be sure that I know about the correct markings for the syringe, because I know we got to draw insulin up a certain way with like regular in the NPH. And I remember last semester there was some discrepancies about like should you mark at the begin, like we know the total, but I think like our professor like docked us if we didn't mark like which one was beginning and which one was end. I don't really know, but I
That
just want to
happened to
make
me
sure I'm
too.
clear on that.
That
Okay.
happened to me too.
Yeah, I can show you how to properly mark the syringe. I have a feeling that question's getting phased out, but I will show you how to do that. What's a three-part question?
So I'm not exactly on the test that I took, it was question, I think it's either 20 or 21. It's the one where they give you the three numbers and then you have to figure out which, I think it's the reconstitution ones.
Oh, you could probably just ignore that question. That looks like I think that's from an older practice set. So technically it's not you're just supposed to choose the strongest concentration. So you're just going to use one of those. So like if it gave you like 5 milligrams per milliliter, 10 milligrams per milliliter,
Dropping
or
her off at home. Sorry.
that's okay. I was like, what? Five, 5 milligrams, 10 milligrams, or 20 milligrams per milliliter, and it tells you to choose the strongest concentration. You just choose 20 and then solve for the milliliters. But I don't know that we ask that question anymore. I'll look for what the reconstitution updated question is on here, and then I'll point you to it. Some of those older ones, unfortunately, they still are there. Okay, yeah, so let's do 15. I just wanted to see if I don't think I had I think I got rid of some of those old reconstitution questions. I'm assuming they did too. So you probably don't need to worry about that. Um, that's what I'm gonna encourage you to do, or just choose the strongest concentration and just solve for it. You don't have to solve all three. Okay, so for this question is like, and I agree with you if you're sitting there going like it drives you nuts. So on the shared OneDrive folder, I have a PDF that just shows you like how to mark it or how it's supposed to look. Because sometimes when I draw it out, it doesn't look like as clean and crisp. Um, but they give you some things. They tell you to draw up 10 units of regular, 40 units of NPH, and then they want you to choose the syringe. Okay, so that's one that students will miss this question about choosing the syringe. And then it wants you to mark with two arrows, and they want you to indicate the what you're drawing up first, and then your total. So a couple things that I do, even though it doesn't tell you to do that, if I'm answering this question, I want to make sure my instructor knows that I know what I'm talking about. So the solution amount to be drawn up first is 10 units of regular, right? So you know that that's going to be drawn up first. Okay, because that's just procedural. It's hard to like draw that out, but I'm going to show you what they're asking you to do. And then the correct total, that's just 10 plus 40, right? So 50 units. Now, where that regular is important. Now, when you're choosing the syringe, this is the same like kind of picture we've been using for years, but you want to look for where it says units. So that tells you which syringe to use. Okay. So don't use this syringe. Okay. That doesn't tell us units, it tells us CCs. Insulin's always measured in units, so we just need to know how many units. All right. So the first thing I do is I go ahead and I put an arrow and a mark at the total. So the total is 50. So I'll put an arrow here, and then, I'll even write 50 units for total. So that's regular plus NPH. Now, what they want you to do and where they want that second arrow is, so when I do my initial draw up of the insulin syringe, okay, I draw up the 10 units first. Then I'm going to draw up the 40 units of U100. So what they're asking you to do in this question is to indicate, even though in reality, there it is. In reality, this is not the case because everything mixes together. They want you to indicate that the regular insulin is here between these two arrows is the 10 units of regulars. That's an R. So I'm just going to reg. Okay. Regular insulin is right in here between the 40 and 50. And then your NPH is all through here. All your NPH is in the 0 to 40 range. The regulars in the 40 to 50 range, and then that's your total. Okay. So I don't think they asked you to shade it, but if I'm marking this syringe based off of what it has said in the reference textbooks, that's what they're looking for you to do. Okay. So the regular is going to be closest to the total. It just happens to be the same mark as the NPH mark. So yeah, you're welcome. I hope that was helpful. Yep, absolutely. So number 16. You're welcome, Charlie. Yep, you're welcome, Misha. Number 16, as a reminder for a refresher, since it's been a semester, in order to do this, it's just taking the flow rate times the drop factor. And that will give you your drop rate. And your drop rate should be in drops per minute. So if your flow rate's already in per minute, leave it alone. Do not convert that to hours. So I'm going to take my flow rate, which is 75 milliliters, 25 minutes, multiply by the drop factor, which is here on the label, 15 drops per milliliter. So milliliters are gone. I'm getting into my drop per minute rate. And I plug that into my calculator, and I'm going to get 45 drops per minute. As a reminder, if you get an answer of like 40.25 drops per minute, you need to round to the nearest whole drop because you cannot give somebody partial drops, right? So if it's 40.25, you're going to round it to 40. If it's 40.65, round it to 41. Okay. Yep. You're welcome. I'll scroll slowly. That way, if you see something, so I'll start back at the beginning. So if you see something that you're like, hey, can we look at that again? Remember, when you're doing your conversions here, like this answer would be 1.275 grams. That's the answer. Don't round that to 1.3. Okay. Do not round your your basic metric to metric conversions. You do round when you go from pounds to kilograms, round to the nearest tenth. Most of these are you've unfortunately, or actually I'll say fortunately, you've gotten in the habit and you know how these things flow together. Remember, if you're answering a TubeX question and it's a paper test, or even if it's a Blackboard test and they ask you to drop a point on your answer, just make sure you mark the TubeX or mark the syringe or whatever they ask you to mark it. Did 15. Mm. I'm seeing this now. So you're going to answer this question the exact same way. So 17 will get answered the exact same way as 16. But what a lot of students end up doing is they look at that 200 milligrams and they go, okay, what do I need to do with that in order to solve that question? When you're doing infusion rates or flow rates or drop rates, you don't need to know the strength to know how to calculate the rate. Okay. The strength is important clinically. It's important for the patient that they're getting the right thing. But when you're doing the dosage calc on this, you just ignore the strength. You just do the flow rate, volume over time. So 70 in this one's 75 over 30 times 10. Okay. And you just calculate the flow rate. You ignore the strength. So it doesn't matter what the strength is when you're calculating flow rates. The only time the strength is important is if you're using that to calculate the volume for like an injection or for an oral dosage, like a liquid dosage. Then you need to worry about that when it comes to milligrams, milliliters. But this just tells you we want to make sure we're giving them that amount, 200 milligrams via IV over 30 minutes. But when we're calculating the flow rate, I just need to know what to program the number to. And hopefully the right medication is in there. I'm assuming that's part of your, what do you guys call it? The 5 rights? Is that like where you check off everything that you're doing? Go ahead, KR.
I had a quick question, real quick. It was about the very first one that we did. It was just about the rounding in it. I get the whole concept of how to, convert into kilograms and then multiply by the unit. And then if I'm doing a bolus, I'm just, putting a bolus in. And then if I'm doing the other conversion to do the flow rate or the IV rate, then I'll do, with the 250 and the 25. But on the last one where it was 70.9 times 20 units multiplied by 250 all over 2500, I got in my calculator came out 141.8. So I'm just trying to understand the logic behind that rounding, because this is the first time I've seen rounding and I'm like, how did they get 14 point something? Like,
So you want to check that bottom number, so it should be 25,000,
oh yeah, 25,000.
and
Okay, yeah, 100.
that'll probably clear that up.
Okay, sorry, thank
No,
you.
no, I'm glad you asked, because this is something that happens to students all the time, and they're like, this doesn't look right. Maybe when I do this on the test, I'll just move the decimal over one more place. It's like, don't do that. Find out, or ask me like where you went wrong, or sometimes I'm wrong, right? So sometimes I'll make that mistake, and or I've keyed it wrong, or whatever the case may be. So I'm glad that you brought that up, because I guarantee you someone else has made that mistake.
Yeah, because I didn't want to say it at first, and I said her, I did it like 4 times. I'm like, all right, how did they get 14? But I see I was missing a zero. I threw it in, and now I got the 14.18 round up. So now I know where I came from. Thank you.
Perfect. Yeah, you're welcome. I'm glad, like I said, I'm glad you asked that question. That was perfect. Perfect question to ask. I did add a question in here that was just in case you have to do something like this where it asks you to like use military time. I find that like sometimes you get asked this question, sometimes not. I don't know what's changing. So it tells you that your shift runs from 7 to 3. You're making your rounds at 7:30. And then you have an infusion rate of 125 milliliters, 125 milliliters per hour, and it's 500 milliliters is remaining in it. So I just wanted to mark kind of the important things here. And then it says you're supposed to do a continuous infusion. And then when should you hang the next bag? So some of this is, you know how to do this. It's just some kind of nuance type things. You want to make sure you know, like, so if I'm solving how many hours this is going to take, I can either just do it in my head, or I'll set it up like this, where my infusion rate, and I'm trying to calculate my time, it would be 4 hours. Okay. So, or if some of you just probably just do, okay, 125 and then an hour goes by and then 2 hours would be 250, 3 hours would be 375, and then 4 hours would be 500. Or you could set it up like this, or you could do ordered over available. That probably works too. The next thing is you started at you started at 0730s when you started your round. What's 4 hours from this time? So that's where you're just adding the 4 hours, and you should get 11:30 is what you would put in as your time. Okay. So the question was, the trick for military time conversions in the afternoon is just the time plus 12, like 2 p.m. plus 12. Yeah, that is, yeah. Or sometimes I just like when I was learning military time, um, I would wear a watch, and I made it. I just left it in military time, and then over a short period of time, like I just picked up on what it was. So like I don't even think about like what like. I'm glad that you're doing that, but like I don't even think about that. I just think about like we have 24 hours in a day. Midnight is 0, so that's midnight, and then 11 p.m. is 2300, and then I just try and like kind of fit along with those things. But yeah, if you add the 12 after when it's a PM, just add the 1200, and then you should be good. Yeah, uh subtract 2. Yeah, so that's another strategy um to do that too. So, yeah. Yeah, there's a couple different ways. I would suggest, like I said, if you have even on your phone, just for like a period of time, convert it um to military time so you're getting the habit of seeing it. And then do what, either do what D said with it, which is just subtract 2 from the number, and it just reminds you that, like, 1900 hours is 7 p.m. The 9 minus 2 is 7. 1500 hours would be 3 p.m., that sort of thing. Or you can add the 1200 after the PM time. Good. Good, good, good. All right. Um, so I'm wrapping up here in the next 2 minutes. Are there any kind of last minute lingering questions? Okay, let's see what this says. Okay, so that's the OneDrive. Oh, okay. Um, okay, so I'm being asked what to ignore. You don't need to ignore the 230 lab packet because that's just what they sent you. So it should just be a copy of what they already sent you. Yeah, you don't need to worry about the pediatric dosage calc. You're gonna do pediatric dosage, so you will need that, but that's during the semester. And then so you want to do that. For non-milliliter values, round to 1 digit, except for drops. Um, Not necessarily. So, like if you're going from pounds to kilograms, round to the nearest tenth. If you're going from ounces to milliliters or milliliters to ounces, you might need to round to the nearest tenth. So it's not always 1 digit. Uh, yes, you will have 2 dosage calc exams this semester. The second dosage calc exam will be during the semester. I think it's for 230. It's the pediatric dosage. So you'll have a separate like prep for that. You'll prep it in class. I have the I have a review already posted on my YouTube channel for that if you need it as a review. Most students, I don't even hear from people anymore. You just got to practice the things. But if you do have questions, you can reach out to me. Um, and Thursday, yeah, it'll probably be fairly similar because the main thing that you guys are doing that's new is the heparin protocol. So I'll probably start off and do the same sort of strategy. Yeah, I'll probably do more on heparin protocol on Thursday. Um, oh, okay. Yeah, so you always go to the 10th place after, if you have a number greater than 1, then calculate to the 10th. If you have a number less than 1, calculate to the 100th. That primarily revolves around milliliters, but it can be associated with milliliters per hour as well. And then you would follow that similar strategy when you're converting pounds to kilograms, or the other rounding things. But also keep in mind that when you go from like milligrams to grams, don't round your answer. Just leave it as it is. Those are just like the first like 5 or 10 questions at the beginning of every test. You're not necessarily rounding those. Yeah. Okay. I think I answered everyone's questions. So yeah, so Thursday would be similar. I might instead of doing this heparin protocol though, I'll do another one. And then I'll work through some of these other questions. So like this is my copy of this. So I'll go back and I'll just start answering some of the questions or working through some of the questions that I didn't go through. And if you can't make it on Thursday, I'm gonna record it. I'll post it on YouTube. And then if you have questions between now and your test next week, please email me. And I'll see you guys maybe Thursday. You're welcome. Happy that I can help.